Alright, let's review Activity 3, which involved the critical reading of Larson's article on the research conducted by the La Florida Bioarchaeology Project. The first thing I asked you to do was identify the overarching research question posed by Larson and his team, which was, how does the introduction of the Spanish missions in La Florida change the lives of local Native American populations? Larson and his team attacked this research question using the two main approaches to the study of death and dying that we're learning about in this module, bioarchaeology and ethnographic analogy. The second part of this activity asked you to explain how they were able to reconstruct the diets of Native Americans living in the La Florida region and what their findings were. So for this particular topic, they analyzed carbon and nitrogen isotopes to compare sets of skeletons differentiated by space and time. And what I mean by that is they were able to keep those skeletons that were found along the coast separate from those that were recovered at inland sites or from the missions themselves, as well as distinguishing those dating to the early or late prehistoric and mission periods. The principle behind isotopic analysis is that carbon and nitrogen enter our bodies through the foods that we consume. So those people who eat more seafood have higher proportions of nitrogen in their bones, and those who consume more corn in their diet have higher proportions of carbon. Now, based on the chart that was presented in the article, and I've included here, we see three trends. The first being that coastal pre-mission populations, that's the set of empty symbols in the upper portion of the figure, consumed nitrogen-enriched seafood. The second thing is that pre-mission populations, so those are the empty and filled symbols on the left-hand side of the figure, consume primarily C3 plants, so that's a lot more fruits, nuts, and grasses. And the third thing is that mission populations consumed more C4 plants or maize, and so those are the three symbols that you see in the little box labeled mission. Overall, the introduction of Spanish missions resulted in a more homogeneous diet, which we can observe in the bones of the populations directly. Next, you were asked to describe the evidence for one sign of stress among the skeletons of La Florida, and Larson gave you several examples to choose from. A few of these include enamel hypoplasis, which are the lines that actually show up on people's teeth during periods of disease or malnutrition. There was joint polish and lipping on the bones, and this is an indicator of osteoarthritis, as well as porotic hyperostosis, which are the sieve-like lesions that form on the skull of those suffering from anemia or iron deficiency. An important thing to keep in mind is that by focusing only on the skeleton, we're missing some diseases that may have killed people prior to manifesting skeletally. For example, smallpox, which we know from the ethnohistoric record, that is, reports from other missions that this was happening in some places, but obviously not everywhere. So this brings us back to that concept of the osteological paradox that we discussed in the bioarchaeology lecture, so being very careful in the comparisons we're making across different populations and all of the factors that might have contributed to what we're able to observe. Finally, I asked you to identify the ethnohistoric practice that the team investigated using skeletal analysis and how they went about doing so. The practice to which I was referring was the repartimientos, so these are places where indigenous people were put to work as draft laborers. The independent evidence of this practice that Larson and his team were able to uncover included not only the osteoarthritis observed in the joints and along the spine, but by measuring the cross-sections of humeri and femora, they found that Native Americans who worked for the missions had thicker, stronger bones that were adapted to more demanding labor. This is an important finding, but bone size can also be affected by other factors, so this method is not always 100% correct.